Wonderful. Well, thank you so much for the introduction. And thank you so much as well for the invitation and to Meryl for organizing and colleagues this fantastic workshop. I can't tell you what a pleasure it is to be here, the bottom of the world, taking part in this very international, dynamic, and just worldwide meeting that's bringing together so many interesting minds and thinkers and perspectives. So yeah, it's, as I said in my tweet earlier today, it's like being in a candy shop with all of your favorite thinkers and ideas. So I just feel really delighted to be part of this. So thank you. My talk today will be kind of in two parts, not exactly of equal portions. I'm going to talk a little bit about a theoretical piece that I published recently, kind of talking about what we as cognitive and brain scientists, which is what I am, might be able to contribute to this endeavor of understanding how humans and machines, and in particular humans and robots, might work together harmoniously in the future. And then I'll talk just a little bit of a whistle-stop tour about some of the research that's going on in my lab, but you'll have heard about some of that yesterday from Maki Ruxby, and you'll be hearing some other fantastic lab-affiliated folks today with Nate Caruana and Ruud Hortensius. So we have a lot of kind of lab love spread throughout this conference. So I'll leave a lot of the really exciting stuff to them to tell you about. So I'd like to begin by placing this research and kind of my interest in it in a little bit of a broader context. So as we've been hearing about pretty much since the start of this workshop, there's lots of interest and excitement for what the future for artificial intelligence holds. And one aspect that is really capturing people's imagination and attention, perhaps more than any other, is the widespread introduction of artificially intelligent superhuman robots, the likes of which we've all come to know and love and or fear from films, books, and TV shows, some of the examples that you see here. So while we're all sober enough in this workshop to appreciate that we're really far off from any sort of superhuman machine like we see Hollywood depicting, and I think Michael Winikoff gave us a really good indication of that in his keynote this morning, that's not happening anytime soon, there are still a number of different robots that are making inroads into our social spheres and social spaces and into kind of really close and intimate human interactions, and kind of understanding better how people might be able to work with these robots and kind of what's going on, what the neurocognitive mechanisms and consequences are when we do introduce and interface with these intelligent machines in these social spaces, what those consequences are going to be. So, you know, there's been a proliferation of machines and other sorts of artificial agents that are designed ever more intelligently to engage people on a social level. But our understanding of how, like, what's actually going on psychologically and cognitively and neuroscientifically in the human brain, this remains really, really rudimentary. There's this kind of heuristic, this rough idea that, well, we know more and more over the past 20 years or so about social cognition and social neuroscience and what's going on in the human brain when we're interacting with other people, though our understanding of that is still very, very basic. So there's this kind of heuristic that, well, maybe we're using kind of the same mechanisms, the same sort of machinery to make sense of robots and other artificially intelligent social agents that we encounter. So there's this kind of, well, maybe they're kind of similar-ish. And what I would like to argue in the first part of this talk today, and what we talk about in this recently published TICS paper, is that it's probably going to be a lot more complicated than just using human social cognition as your kind of rough heuristic for understanding what's going on when we're perceiving and interacting with especially physically embodied robots. There's a number of other things that I'll touch on that I think is going to be really important, I think are going to be really important for us to consider and to study deeply as well. So hopefully this endeavor of how we perceive and interact with artificially intelligent social machines can very much be aided by the cognitive and brain sciences. But you might be sitting back and saying, well, why should we actually care about, what's going on in the human side of human robot interaction? Well, I would argue there's two really good reasons why we should care about this. One is that if we can understand what's going on in the human brain and cognition and behavior when we're trying to engage in a meaningful way with social robots, this should help us to improve the design and programming and make these agents ever more socially engaging and collaborative. And that, of course, is precisely what we want them to do in order to help us in social roles. So that's one piece. But the other piece that is very much of interest to people working on the human sciences and the cognition and neuroscience side of things is that a better understanding of the flexibility and limits of human neurocognition when we're engaging with people or artificial agents should help us to understand the human brain and kind of its basic mechanisms in a much better way. So I would say there's just kind of two complementary, both really important reasons why we should care about the human side of human robot interaction more. So thinking about how to best position this research within this fledgling field, we have social cognition, which has so far been kind of the wedge that a lot of this research has focused on. So lots of comparisons between people and robots. What happens when you look at people, when you interact with people compared to when you interact with robots? And that's great. It's given us a really good start. But I'm going to argue that if we kind of widen our perspective or our lens or some of the factors that are going to be really important to also consider in this endeavor, we're going to come up with a much better and a much more complete understanding. So one of those things that we're going to have to really think about carefully and often gets kind of swept under the table between studies and when people kind of pluck and human robot interaction studies to kind of support their psychological claim are all of the complexities that come with machine variation and how, there's no not that any two humans are created equal, but any two machines are definitely not created equal, and that isn't really taken into account as much as it should be. Also, I'm going to argue for broadening the perspective beyond social cognition to be thinking about what we can learn and what we can gain from considering diverse brain systems. And finally, I would argue, and I will argue, that there's some particularly unique challenges, especially for those in social cognition and social neuroscience coming to the table to take part in this research endeavor that we're going to have to carefully think about how to take into account. So the first pillar of this framework that we propose in this paper is this idea of respecting the important and distinct roles played by machine variation. And there's just a few kind of sketches of what those types of machine variation are in that box there, but let me sketch this out for you in a slightly different way. So we're thinking about machine variety. And when we think about machine variety, let's start with people, which are very much not machines, but we have a lot of experience with people, and we kind of know that each of the three individuals we see pictured here, those are people. There's no question about that. And yeah, they're famous people. We might be familiar with kind of other information about them, but those are people. But then we can start to think about how we might think about and embed our knowledge of machines and socially intelligent machines. So we can think about objects, and objects are very distinct from people, and that's very clear. There's a lot of kind of space in between them. But then we can drill down into objects like in an ever more specific way. So we can think about a type of objects that we kind of interact with to achieve certain goals, which are tools. We can think about even more sophisticated tools, which are machines, which we can achieve all manner of even more complex and sophisticated goals with. And then over the past 20 or 30 years, we've had the advent of artificially intelligent machines that might not look like much on the surface, but can achieve all manner of even more sophisticated tasks. And then kind of drilling down and bringing us, as you can see, ever closer, perhaps, to humans, we have artificially intelligent social machines. So these aren't just machines imbued with artificial intelligence, but these are machines that are specifically designed to engage with us on a social level. And we can see there's a lot of variety within that object category right there, especially as we get down to these artificially intelligent social machines. But I'm going to argue that maybe we should not just be thinking about these really strict categorical axes or categorical differentiations that we see here, but we can instead think about different dimensions or features of objects. And this might bring us much closer to kind of understanding what's going to matter when we're interacting with or perceiving a robot, for example. So some of the dimensions or features of objects that might be really important depending on the task at hand include your prior experience or expectations, their functional repertoire, form to function mapping, how big they are, how social they are, how intelligent they are. Do they have a human-like form or a very unhuman-like form? And if we kind of take this more kind kind of feature mapping approach, we can start to kind of say, okay, well, different objects as we go through the object space here will have really different properties and dimensions based on what their design is and what their intended use is. So we can also see here that objects that might be in the same category in the left-hand column have really different features. So it could possibly be quite a fruitless task to focus on categorical distinctions. And instead, maybe when we think about machine variety, we can think more about different dimensions rather than just categories. So that's kind of one challenge, and it's not easy to kind of take into account, but I think it's something that we should be thinking about rather than just that's a robot, that's a human, or that's a tool, that's a robot, that's a human. The second pillar of this framework is speaking to the proposal or the strong urging to take into account not just social cognition, but diverse and interacting cognitive and brain systems that will be required to support successful human-robot interaction. So you can see a few here. We have object, tool, social cognition, semantics, attention, memory, and of course, social is just one small piece of that. But so far, there's been nearly an exclusive focus on how people perceive and interact with robots versus humans. And this is going to run a real risk of overemphasizing the human-like or social qualities of a robot and how important those are for human-machine interactions, when indeed it could be many other features that are more important. And it's not just the kind of human-like socialness that's most important. And in another paper that you might hear more about later today, I'm not sure if Ruud will be talking about this, but in this review paper that Ruud, Anna, and I from the lab wrote last year, we kind of talk about the importance of object-specific brain regions and what's going on when we're interacting and perceiving robots in these object representative brain regions, and how these are going to be really important as well. So it's not just human-based social cognition. What are parts, what's FFA, what's EBA, what are these STS type regions doing? But let's think about object categorization and cognition and the neural substrates of this as well. So yeah, moving beyond social cognition is going to be important. And the third and final pillar of this new framework is one that I think is really exciting, but is perhaps the most challenging. And this concerns the unique challenges and opportunities that studying human-robot interactions or kind of people's engagement with social robots might present. So we have a bunch of different challenges that are listed in this blue box here, but I'll just highlight a few of them and why they're particularly, going to be something that is going to take our field a lot of time to really kind of come to terms with and make sense of. So the first is novelty and lack of experience. People just don't have a lot of experience or know what to expect with when they see a robot kind of plopped on the table in front of them. That's a really good and interesting thing, but it also means that everyone's going to be coming with different expectations. Another really interesting fact that again, just doesn't get spoken about all that much, especially when people from psychology and cognition start to look at human-robot interaction research, is the whole thing with the Wizard of Oz setup. So almost, not every, but I think there was a statistic that was just published that roughly 80% of human-robot interaction studies, and indeed a lot of these that are in psychology, there's an experimenter pulling the strings behind the scenes. So the robot is not behaving autonomously. And if we're trying to understand how people are going to engage with and build relationships with and cooperate with autonomous artificial agents, we cannot be using Wizard of Oz the whole time. And we have to be really clear that understanding that there's a person essentially treating a robot as a puppet, this is really different than having autonomous robots. And this kind of these are all variations perhaps on the same theme, but people have really skewed or vague expectations, which kind of comes back to this first thing about novelty and lack of experience. But the more and more we see these beautiful images that, just are all over Google about robots, beautiful robots doing really clever and sophisticated human-like behaviors, then people start to have expectations that this should be what robots might be able to do. And there's a lot of really good research the world over that's kind of looking at this mismatch between expectations and reality, but that work needs to continue, and we need to kind of take that understanding into all of our work in this domain. And, again, coming back to Michael Winikoff's warning this morning about media influences. So he was talking about really knowing the expertise level of someone who has a breathless proclamation about, what AI is going to do and how it's going to destroy your life. Well, I think we also have to think about media influences with human-robot interaction, because we have seen so much throughout the years and throughout our Netflix scrolling of robots doing all manner of things that we're just not going to see them do anytime soon. And just kind of understanding whether people are sci-fi buffs, whether they've kind of seen lots of Pixar movies, or they, kind of were frightened of Terminator as a kid. All of these things are going to really shape interactions with and perceptions of robots in ways that I would argue we don't see this as kind of importantly and as widespread in other areas of cognition, of human cognition. So to sum up kind of the points of what we're proposing in this paper, what I'm trying to suggest as for a new field of social robotics and kind of human cognition meets social robotics, it's far more complex than just social cognition with robots. What we're trying to put forth in this paper is a way that we can frame or approach this complexity. And this proposed framework is really trying to harness key insights from cognitive neuroscience, not just social cognition, to address the novel and really unusual demands posed by human interactions with social machines. And as I say here, true progress in developing machines that engage us on a social level will really only come with interdisciplinary collaboration across the social, life, and computing sciences. And I think the Social Bridges workshop is really trying to build some of those bridges nicely. And I would like to say that cognitive and social neuroscience have a lot more to offer social robotics than just social neurocognition with robots. We can do better, we must do better, and we will do better. And what we lay out in this paper is just one way to approach the complexity of the task at hand. So that's kind of the bulk of the talk. Now I'm going to give you just a sneak peek, because we have, I think, about 3 to 7 more minutes here to talk about some of the work that's emerging from our lab. And I should say that this theoretical piece is a new piece, and everything that I'm going to show you here hasn't followed those kind of lofty ideals yet, but it's kind of a way that I want to think about framing research within the lab going into the future. But there's still a lot of low-hanging fruit to be done using, depending on what your question is, social cognition comparisons. So we have a wonderful cast of characters that's in our lab right now, actually across our labs at Glasgow and here in Sydney at Macquarie University. And we're really interested in kind of asking questions about social cognition as they relates to social robots into the future. But again, when I say social cognition, I don't mean just sticking with that, but kind of taking this broader perspective, this bigger, wider lens for that. So one question that we might ask is, how can we examine social specificity versus domain general neuroprocessing and behavioral strategies when we engage or socially engage with robots? This is a really nice paper with Rude that came out a few years ago, where we're trying to kind of map some of the neural areas that are probably going to be key targets and really relevant as we kind of take further steps towards this endeavor. And just a real quick kind of overview of some of the latest findings and questions that we're asking and trying to answer in the lab. We've been doing some work with synchrony and social reward and trying to understand the extent to which synchronizing with a robot makes you feel more amiable towards them. And the kind of spoiler alert here is that it's not a very robust finding, but the beauty of pre-registered research and kind of staying what our hypotheses are and what we're basing them on means that hopefully that we won't have the file drawer problem, and you'll just see all the positive results published, but you'll also see some of these really robustly supported null effects. We're also looking at some interesting questions with prisoner dilemma games and other economic games with robots, and the extent to which people show social reciprocity when they're competing against robots. And some even more recent work with T.E. C, who's the first author on that, is looking at the impact of emotion, of robots' displays of emotion on cooperation. Also, the extent to which we perceive robots as social agents and how social perception might kind of interfere with other sorts of cognitive processing in the human brain. Some nice work by Anna Henschel and colleagues that just came out this year in Collabora, and some really cool stuff with a collaboration across London and Edinburgh and Glasgow and Macquarie, looking at kind of linguistic framings of robots and different races of social interactions. And that's such a cool study, and I can't wait to tell you more about it as data come in. Some really nice work as well with the PhD student Guy Laban, looking at emotional disclosure to robots and the extent to which robots might be a useful tool for kind of having people talk about concerns, problems, etc. And again, lots of really exciting things happening in that space, having to do with COVID as well right now. And that's something I'll tell you just a little tiny bit about here, is the extent to which you might be able to build more empathy for pain expressed by a robot after long-term social engagement. So I know we only have just a few minutes left. I'll just tell you a few things about this study because it was I think an interesting study. We nicely pre-registered it and had some clear ideas for what we expected to find. But as always in real life research, the findings are not quite what we expected. So our question here was, to what extent can, if people spend a lot of time interacting with this really cute little palm-sized robot Cosmo, which some of you might be familiar with, if people take that robot home for a week and really kind of play lots of games with it, to what extent will you start to feel more empathically towards that robot when it looks like it's in pain? With this kind of like pretend electric shock therapy. So what you can see here is just a video and there's sound, but you can't hear it. But what participants were seeing here was a little video of the robot with a circuit board behind it. And when the red light went on, the robot was supposed to be shocked, and the robot would either have kind of like really kind of uncomfortable, shocking, and have these painful expressions and vocalizations, or we'd say that there could be kind of a nice stimulating massage shock paradigm, and the robot would look very happy. And we also had those exact same conditions emulated with a human actor. And again, no robots or humans were actually harmed during the making of these videos. And what we did was we sent participants home then with the robot in between kind of identical fMRI sessions where we scanned their brains while they watched these different videos of the humans and the robots kind of in pleasure or pain. And we asked people to spend at least a half hour a day kind of getting to know the robot, playing games with it, socializing with it, etc. And gave them lots of instructions about how to do that. Our participants really enjoyed the task. They gave us all sorts of wonderful photographs of them getting to know their Cosmos at home. And I think quite a few pets were made jealous. But just to show you one of the many findings from this study, we functionally localized brain circuits that we know to be involved in empathy by using this partly cloudy functional localizer task from Rebecca Sachs's lab in the States. And what we were really interested in was the extent to which, after participants spend this week interacting with the robot, do we start to see that there's kind of more engagement of kind of human robot overlapping within these empathy related brain regions. Well, these are regions for pain, empathy in the human brain. And it's a little hard to go through everything that's going on in this slide, but essentially what we wanted to see was these two traces on the plot here showing quite a lower position after the week of training. So kind of to be lower than the two gray dots. And as you can see, there's really no differences. So what we concluded from this study, and again, I'm not doing it justice, it's a long paper, please read it if you're interested, but we found no evidence for neural mechanisms associated with empathy towards people to really kind of show more overlap between humans and robots after you socialize with a robot. So there's kind of, these are quite distinct things, and we can't just kind of trick people or convince people that robots are kind of going to deserve empathy in the same way that humans do. That's just one study, that's just one robot, but it's kind of an exciting space. We have lots of other stuff going on, which I'm going to skip over because we're out of time. I'll just finish off with two quotes, which were, one is that's by technology writer Eric Sofke, who says we're only barely scratching the surface of the brain's social algorithms, which become even more complicated and unpredictable when we interface with technology. I couldn't agree more. And another fantastic psychologist working at the intersection of robotics and brain sciences in Auckland, Elizabeth Broadbent, suggests that the further we go down the path towards making and interacting with artificial humans, the more truths we learn about ourselves. So I think just, again, a really nice interdisciplinary perspective. Do I have any fine thoughts to say? How will humans and AI interact in 5 years? I don't know, but I think that we're only going to be able to answer this question by bringing together people working in the mind sciences and brain sciences, cognition as well, to begin to get good answers to these questions. I think Maki had a slide up for this yesterday, but I would like to encourage anyone who's interested to come along to our virtual social interactions workshop, which is free, and it's going to be happening in June and July this year. Some fantastic keynotes, and we'd love to have any of you interested come along. And I'll finally be quiet and I'll thank my team members and funders, and I'm happy to take any questions. Thank you.
Thanks so much, Emily. That was a wonderful talk. I learned a lot on kind of the interdisciplinary nature and the combination of neuroimaging with the social aspects. That was fascinating. Thank you so much for the talk. taking the
Thank you.
time to give the talk, first of all. I just directly move to the questions because we have a couple. As we move away from AI tools to AI social agents, should we worry about humans exploiting AI agents in ways in which humans do not exploit humans?
Great question. And I think we absolutely should worry about that. And I think the wonderful thing is that there's lots of people who are working on this in this space. I think there's quite a few people in the Netherlands in particular that seems to be a hotbed for these sorts of questions and issues. Yeah, I think there's a lot of people who have their finger on the pulse of this, and this is where we're going to need even more interdisciplinary work from philosophers, from lawyers, from people who really kind of understand the ethics deeply. And yep, I think we should be concerned, but fortunately, people are kind of working on it now.
Yes. The next question, if robots look a lot like humans, will we start to treat them more like we treat other humans, or will we start to treat humans more like we treat machines?
Oh, no, that's a really cool question. So I think the first half of that question, if robots look more like humans, will we start to treat them more um, like humans? The evidence for that so far is mixed. And again, kind of coming back to that first pillar, talking about machine variation, it's really hard to kind of say, well, there's these 4 studies that have found this, therefore we can conclude that this is what happens. It's just every machine, every robot is different. But I don't think the evidence so far is compelling or clear that the more human-like a robot becomes, the more human-like people treat it. It's complicated. But this idea about kind of then treating humans and to be more machine-like, this is another really interesting question, but we also need philosophers and ethicists and people who really can get at these questions in subtle and nuanced ways, because I don't think we know the answer to that yet. But again, I think it's something we probably should be concerned about and at least, keeping our eye on.
Yeah, something to be wary of at least, right?
Yes.
I would agree with that. The last question: when do people cooperate, and when don't they? When they interact with robots in social dilemmas? You mentioned the prisoner dilemma.
Yeah. So this is again an emerging space. There's not a ton of work, but in our particular task with our particular robot, I know it sounds really boring to keep saying that, but I think it's important because we can't say like, oh, well, we found that people do this with robots, but with our task, with our robot, we find that people really use much more of a tit for tat strategy with robots than they do with humans. So if the robot cooperates, they cooperate. If the robot competes, they compete. And we really see this kind of not so much an escalation, but just a tit for tat strategy for the prisoners dilemma games that we found with our people and our robots. So again, like these questions are really of interest to lots of people designing kind of co-working robots, especially working with people on factory floors or even kind of in more decision-making type tasks. So I think this is a very open area, and I'd like to encourage people who are interested to please come and do more research in this domain because it's needed.
Yes, especially the cooperation part seems to be super relevant and interesting. Like you can implement very, basic cooperation tasks, like in the factories where you have these tasks and they need to do some communication, and then you could do even far-fetched ideas. Like probably the closest way would be what Gordon Chang yesterday presented yesterday at his talk, where he showed artificial skin, where this kind of next robot style, which is more sensory involved in the environment. But with that, we have to leave it there. Emily, thank you so much again for taking the time and for that great talk. And look forward to the future state and the future presentation we have later from your lab as well.